Hello everyone, welcome to my channel Physics Tricks. So in this video I'll be giving solutions to the problems which I gave in DPP 2 and DPP 3. So see here, this is the ninth question which I gave homework, and it is: a stone is allowed to fall from the top of a tower 300-meter height, and at the same time another stone is projected vertically up from the ground with a velocity of 100 meter per second. Find when and where the two stones meets. So over here, as you can see, this is the 300-meter height pole given. So this is 300 meter we have, and if we just throw the stone upward with a velocity of 100 meter per seconds, and another stone is just released, right? That indicates initial velocity is 0 meter per seconds. When and where it will meet? So let us consider the from ground at a distance of x it will meet. So from the top it will become 300 minus x. So we'll calculate now. So firstly, if we write the x equation, it will become x is equal to ut, that is 100t minus half gt squared. And if you write 300 minus x expression, 300 minus x is equal to u is 0, 1 by 2. Now why 300 minus x is negative? Because the displacement is downward, and half minus g into t squared. So if you just solve this, you will get 300 minus x is equal to 1 by 2 gt squared. Now put this x value over here. So it is 300 minus 100t plus 1 by 2 gt squared is equal to 1 by 2 gt squared, and if you can see this get cancelled. So 100t is equal to 300. So what is t? 3 seconds. So that is when they will meet. They will meet at time t is equal to 3 seconds. And at what distance, at what height from the ground? It is 100 into 3 minus 1 by 2 into 10 into 9. So if you just solve this, you will get 300 minus 45, which is 255 meter. So 255 meter from the ground, at a height of 255 meter they will meet, and at time t is equal to 3 seconds they will meet. So I hope this is clear now. Now the next question, 10th question solution I gave. 11th question: a body thrown up with a certain velocity reaches a maximum height of 100 meter. Reaches a maximum height of 100 meter. Find the maximum height of another body with double the mass thrown up with double the initial velocity. So see, when we throw a body with velocity u, it reaches a maximum height of 100 meter. Now if you just throw the body with mass 2m, this mass is given m, with double the velocity 2u, it will reach the height h. This h we want. Now as you can see, in the maximum height formula, it is u square by 2g. Mass is not present, so over here also u square divided by 2g, but instead of u, you have to write 2u, so it will become 4u squared by 2g. This is given 100, that means u square by 2g is 100. So what is the height if you throw the body with double the velocity? It is 4 times the given height, that is 400 meter. Okay, so I hope this is clear now. Now the next question: if the distance traveled by a freely falling body in the last second of its journey is equal to the distance traveled in the first 2 seconds, find the time of fall. So I'll just draw the diagram. It will be clear if you understand through the diagram. One body is thrown, right? One body is just released, and whatever distance traveled by this body in the first 2 seconds, so s2 seconds, is equal to the distance traveled in the last second, right? So distance traveled in nth second supposed to be. So a distance traveled in 2 seconds must be equal to the distance traveled in nth second. So distance traveled in 2 seconds for a freely falling body will be ut plus half at squared, but u is 0. That's why I'm writing directly half minus z into t squared is equal to, what is nth? U is 0 here also. So minus z by 2, 2n minus 1. So minus z by 2 get cancelled. This t squared is nothing but 4. is equal to 2n minus 1. So 2n is equal to 5. So what is n? It is 2.5 seconds. So I hope this is clear now, right? So likewise, you need to solve the question. So these are the questions which I gave as a homework in from DPP 2. Now we'll solve questions from DPP 3. So these are the questions from DPP 3 which I gave as a homework. So 7th question, a particle starts from rest with constant acceleration for 20 seconds. If it travels a distance y1 in the first 10 seconds and distance y2 in the next 10 seconds, then what is the relation between y1 and y2? So I'll just draw the diagram over here. In the first 10 seconds, it travels a distance of y1 supposed to be, and in the next 10 seconds, it travels a distance of y2, and the uniform acceleration is given. So we can write y1 is equal to ut plus half at squared. U is 0. Why? Because it is given rest. So half a into t squared as 10 squared. And if we take y1 plus y2, it is equal to, now why I consider y1 plus y2? Because we don't know what is the initial velocity at this point. So consider y1 plus y2 and put y2 over here, y1 over here, you will get y2 right now. So it will become 1 by 2 a into 20 squared. Now put y1 over here, you will get y2. So y2 is equal to 1 by 2 a in bracket 20 squared minus 10 squared. Just rearranging, right? So y2 you will have a by 2. This is 20 minus 10, 10 into 30, right? 10 into 30. So if one, what is y1? y1 is a by 2. It is 10 squared. So if you just take a ratio y2 divided by y1, you will get this a by 2 get cancelled. So 10 into 30 divided by 10 into 10. So this get cancelled. It is 3. So we have relation as y2 is equal to 3 y1. y2 is equal to 3 y1. So I hope this is clear. y2 is equal to 3 y1. That is option B. Next, a train starts from station with an acceleration 1 meter per second squared, and a boy who is 48 meter behind the train with a constant velocity 10 meter per second. The minimum time after which the boy will catch the train will be. Okay, so this is the boy which is moving with constant velocity, and that is 10 meter per second, and the train just started with a velocity of with the acceleration of 1 meter per second squared, and the velocity is 0. That means just started. So let us consider the train travels a distance of x. In that time, he has to travel a distance of what is called as 10. This is what is this 48 meter now. 48 meter behind the train. 48 meter plus x, that is 48 plus x. So just write down the equation. So 48 plus x must be equal to what? 10 into t, and this train will travel a distance of half a t squared. So put it over here. So 48 plus x is t squared divided by 2 is equal to 10 into t. Now multiply by 2. It will become t squared plus 96 minus 10t is equal to 0. It is 20t. So we have t squared minus 20t plus 96 is equal to 0. And if you just see, it is t minus 12 and t minus 8 is equal to 0. So t is equal to 12 comma 8. Now why we got two answers over here? Because what will happen while traveling, right? While going towards the train, it will cross the train one time and it will come back and it will cross train one more time. So but we want the least time. That means least time we have is 8 seconds. It's not the 12 second, it is the 8 second which is the least time over here. Okay, so next question. And it is given a particle moves 200 centimeter in the first 2 seconds and 220 centimeter in the next 4 seconds. With uniform deceleration, the velocity of the particle at the end of the 7 seconds is, now the answers are given in CGS, so I'll solve everything in CGS. So it is 200 centimeter in first 2 seconds and 220 centimeter in the next 4 seconds. So firstly, write down the displacement formula. 200 s is equal to u is we don't know, and the acceleration also we don't know. So ut plus half a t squared, u into 2 plus half a into t squared, that is 2 squared. So we'll get 100 is equal to u plus a. This is equation number 1. Now for the entire journey, 420 centimeter is equal to u into 6 plus 1 by 2 a into 6 squared. Take 6 common. It is 70 is equal to u plus 3a. So this is equation number 2. Now from equation 1 and 2, we have u plus a is equal to 100, u plus 3a is equal to 70. Now just subtract minus and minus. This get cancelled. Minus 2a is equal to 30. So what is a then? A we have as minus 15 centimeter per second squared. So this is the acceleration. Now put in any equation, you can calculate what is called as the initial velocity, and that initial velocity is 100 plus 15, which is equal to 115 centimeter per seconds. So if you know the initial velocity, we can find out what is called as the final velocity at the end of 7 seconds. V is equal to u plus 80. We can use u is 115 plus minus 15 into 7. So we have 115 minus, and this is 105, which is 10 centimeter per seconds. So answer for this is 10 centimeter per second. That is option C. Next, the velocity of a particle at an instant is 10 meter per second. After 3 seconds, its velocity will become 16 meter per second. The velocity at 2 seconds before the given instant. Okay. So see here. Let us consider at an instant, as in at 2 seconds supposed to be, we have 10 meter per second velocity. After 3 seconds indicates 5 seconds, its velocity becomes 16 meter per second. We want what is the velocity at t is equal to 0 seconds. V is equal to what? Okay, so find out the acceleration. Acceleration is final velocity 16 minus initial velocity 10 divided by 5 minus 2, that is 3, which is equal to 6 divided by 3, that is 2 meter per second squared. So use this acceleration over here because it is a uniform throughout, right? Because it is a uniform throughout, acceleration is 2 meter per second squared. So we have final velocity 10 is equal to initial velocity we have is v plus 80, 2 into t is 2. So if you just find out this, 10 minus 4, which is equal to 6 meter per second. So I hope this is clear. It's very simple. Firstly, apply the kinematic equation in this interval 2 to 5. Then apply the kinematic equation from t is equal to 0 to t is equal to 2 seconds. And that is the reason you have to always draw the diagram so that it will be very simple. Next, a stone is thrown vertically upward from cliff with a velocity 5 meter per second. Chalo. So it is thrown vertically upward with a velocity 5 meter per second. It strikes the pond near the base of the cliff after 4 seconds. Okay, after 4 seconds it will drop, or it will hit the ground. The height of the cliff is, so we want what is the displacement originally. Okay, now so displacement we want. So displacement over here is minus h, we can say, is equal to ut plus half a t squared. U is 5 into t is 4 minus 1 by 2 into 10 into t squared is 16. So if you just solve this, you will get minus h is equal to, this is 20 minus 80, and minus h is equal to 20 minus 80 is minus 60. So h we have is 60 meter. So I hope this is clear. Next question. A stone is released from a hydrogen balloon going upward with a velocity 12 meter per second. When it is at a height 65 meter from the ground, the time the stone will strike the ground is okay. So as the balloon is moving upward with a velocity 12 meter per second, that stone will also move upward with a velocity 12 meter per second. Always remember, it is the velocity which will be retained by that body, and the force is automatically will become 0 on it by external source. So over here 12 meter per second, it will go up, and it is at a height of 65 meter. It is given displacement minus 65 meter. Time, that is what we want. T is equal to what? So S is equal to ut plus half a t squared minus 65 is equal to u is 12t plus half 80 squared, a is minus 10 into t squared. So if you just solve this, minus 65 is equal to 12t minus 5t squared. So 5t squared minus 12t minus 65 is equal to 0. So now we can have as time as t1 comma t2 is equal to minus b, that is minus 12, plus or minus square root of b square 145 4 minus 4ac 20 into 65 divided by 20 into minus 65 is plus 2a, so that is 10. So if you just solve this, you will get 12 plus or minus square root of, this is 144 plus, what is this? This is 130, means 1300 divided by 10. So if you just solve this, 12 plus or minus root of, this is 1444 divided by 10. Right now, so if what is the square root of 1444? So it is 38. So 12 plus or minus 38 divided by 10, and as you can see 12 plus 38 divided by 10, which is 5 seconds, t1 we have, and t2 is minus 26 by 10, no, minus 26 divided by 10, it will become minus 2.6 seconds we have, but negative time not possible, and that is the reason we have to consider positive time. So 5 seconds is the answer. So I hope this is clear. These all are the solutions of DPP2 and DPP3, and if you want the links for DPP2 and DPP3, you just click on the links which I provided in the description box. Thank you so much.